Hello everyone, in today's lesson we will be discussing derivatives of trigonometric functions. We will find the derivative of the sine and cosine function, find the derivatives of other standard trig functions such as the tangent functions, can then calculate the higher order derivatives of the sine and cosine functions. Previously we derived a limit as x approaches 0 of sine of x over x is equal to 1. We can also derive that the limit as x approaches 0 of cosine of x minus 1 over x is equal to 0. Now let us go ahead and do the derivation for the second one. Limit of as x approaches 0 of cosine of x minus 1 over x is equal to 0. Now let us start by multiplying the numerator and denominator by the conjugates. Once we multiply by the conjugates, we get something called the difference of squares, which we studied earlier. So this is going to be cosine x squared minus 1 squared, and we write that as cosine squared x minus 1 all over what is in the denominator multiplied by each other. So that is x times cosine of x plus 1. Then we factor out a negative 1 because of where we want to go. We're going to look at finding something that we know from before that we can actually simplify or make this expression a little bit simpler. That's negative 1 minus x squared all over the same denominator x times cosine x plus 1. Now this 1 minus cosine x squared we recognize from our identity, and cosine squared x plus sine squared x is equal to 1. We recognize that as sine squared x. So that's negative sine squared x over x times cosine of x plus 1. And then what we want to do in our next step, we want to see that this top part as a multiple sine of x times negative sine of x. So the next step, we're going to separate these two factors of negative sine squared x into sine of x and negative sine of x and put them over some denominators in such a way that one of them looks similar to what we have seen before, which is sine of x over x, and as limit as x approaches 0 of sine of x over x, that will be equal to 1. And then for the other one, negative sine of x over cosine of x plus 1, we can just plug in 0 for x, and so the cosine of 0 is equal to 1. Sine of x is equal to 0, so that's negative 0, which is just 0 over 1 plus 1. So in our next step, we have 1. This part becomes 0, so it's 1 times 0, which is 0. So we have proven, or we have shown, that the second thing that we derived was also true, which is that x, the limit as x approaches 0 of cosine of x minus 1 over x is equal to 0. Now, before working on the derivatives of the trig functions, let us have some fun in practicing some more advanced limit problems using the two identities we have discovered so far. So let us look at one, the limit as x approaches 0 of sine of x over 6x. So let us look at that. The limit of as x approaches 0 of the sine of x over 6x. Now we want this to look something like either the sine of x over the sine of x only, or something like the sine of theta over theta, where we know exactly what that limit will be. So one way we can do this is to factor out the 1/6 out of, or factor out the 6 from the denominator. So we have limit as x approaches 0 of sine of x over x times 1/6. Then by using our scalar multiple rule that we learned earlier, we can pull this 1/6 in front of the limit, so it becomes 1/6. The limit as x approaches 0 sine of x over x, and because we know what this sine of x over x gives as the x approaches 0, then we can go ahead and multiply that by our 1/6, and we know that that was 1, so 1/6 times 1 equals 1/6, and so that is the answer to our first question. For our second question, we have the limit of the sine of 6x over x. And in this situation, we can multiply the top and bottom by 6 over 6. Why? Because we want to have the same thing in the denominator that we have in the argument of the sine. So since we have 6x here on the top, we need a 6x in the bottom to make it look like something like the sine of theta over theta, or sine of x only over x. Okay, so what we want to do then is that we want to set it up so it becomes sine of 6x over 6x times what will be left up here would be just 6, because we put that other 6 with the x. So it would be like 6 over 1, which is just 6. And then by our scalar multiple rule, we can pull the 6 before the limit. So it becomes 6 times the limit as x approaches 0, sine of 6x over 6x. And then that would be 6 times 1, which would be equal to 6. Now let us run across and do the third problem, which is the cosine of 2x minus 1 over x as x approaches 0. So the third problem, the cosine of 2x minus 1 over x. Now what in this case, we also want our denominator to look like the argument in the numerator. So what we have to do then algebraically, we multiply both the top and bottom by 2 over 2. Then it becomes a cosine of 2x minus 1 over 2x times 2. And then we know about the scalar multiple rule again. We can pull the 2 in front of the limit by the scalar multiple rule. So that would be 2 limit as x approaches 0, cosine of 2x over 2x minus 1. But the cosine of 2x minus 1 over 2x is going to be 0 based on the identity or the rule that we found earlier on. So this is equal to 0. This total equals 0. Now let us go back and look at what we can do with this. We can use what we just learned to further prove that some of the identities that we have here are true. For example, the derivatives of the trig functions that we will have to look at, or we have now, is that derivative of sine of x is equal to cosine of x. Derivative of cosine of x is equal to negative sine of x. And then the other 4 trig functions that we will do, that we can derive from using sine of x and cosine of x, the derivatives of sine of x and cosine of x as well, are that the derivative of tan of x is equal to secant squared of x. Derivative of cotan of x is equal to negative cosecant squared of x. The derivative of secant of x is equal to secant of x tan of x. And the derivative of cosecant of x is negative cosecant of x cotan of x. Now what some people use to remember the SIGNS in all of these is that if you look at the functions that begin with c, their derivatives are all negative. So if you look at all the functions that begin with c, like cosine, cotan, and cosecant, all their derivatives have negative SIGNS. Now let us look at a quick proof for the derivative of sine of x. Let's look at a quick proof for the derivative of the sine of x. We know we given that derivative of sine of x is equal to cosine of x. So how can we try to prove that? Now if we remember from the additional rule, the sine of, let's say, a plus b in parentheses was equal to sine a cos b plus cos a sine b, a sine, cosine, cosine, sine, if you remember that rule. Then we can look at the definition of derivative and say for sine of x, so that's the limit as h approaches 0 of sine of x plus h minus sine of x all over h. And then if we apply the addition, the trig addition rule, next step will be the limit as h approaches 0, sine of x cosine of h plus cosine of x sine of h, and then minus sine of x all over h. And then if we continue to simplify this as we go down and rearrange some stuff, we have sine of x cosine of h minus sine of x plus cosine of x sine of h all over h. If we separate these into 2 separate parts and factor So we have sine of x cosine of h minus 1 all over h on one side, and I have cosine of x sine of h over one side. And if we just kind of separate them out a little bit to let them kind of look like some things that we've been looking at, so we have a limit as h approaching 0, sine of x times cosine of h minus 1 over h. Notice this cosine of h minus 1 over h looks like the thing that we did earlier with the cosine of x minus 1 over x, and we know that the derivative as the limit as h approaches 0 of that was 0, and also the sine of h over h looks like the sine of theta over theta, or the sine of x over x that we looked at earlier. So then the derivative of that was 1. So then we have sine of x times 0, which is just 0, plus cosine of x times 1, which leads to cosine of x. And that's the one that we prove. If you look at the graph of it, you can see it probably more clearly from the graph. So let's look at a couple of problems real quick. Find the derivative of 5x cubed times sine of x, and we're going to use the product rule right there. Let's see what we'll do. 5x cubed times the derivative of sine of x plus sine of x times the derivative of 5x cubed. So 5x cubed, we keep that. The derivative of sine of x is cosine of x, plus sine of x, we keep that. And the derivative of 5x cubed, that is a power function, times a quotient, that's 5 times the derivative of x cubed, which is 3x squared. And then to simplify that, rearrange it and do all kinds of stuff. You might want to put the sine of x in front, but it's fine if you keep the sine of x to the left as well. So that's 5x cubed cosine of x plus 15x squared sine of x, and we're done. Let's look at another problem real quick. Let's look at number 6. So number 6, we were trying to find the derivative of cosine of x over 4x squared. Use a quotient rule. Sometimes when you have quotients, you can rearrange them and use them as products, and it's a product rule, and that's fine, but let's use the quotient rule right here. So then that would be low times the derivative of the high, that's 4x squared, times the derivative of cosine of x minus high d low, that's cosine of x, times the derivative of 4x squared all over 4x squared all squared. And then the derivative of cosine, that's negative sine of x, 4x times 4x squared minus cosine of x times 4, and the derivative of 4x squared, which is 2x, so that's cosine of x times 4 times 2x. And then we can expand this and then factor. Okay, expand negative 4x squared times sine of x minus 8x times cosine of x over 4x squared squared. Then we factor out of 4x. We have negative sine of x, x sine of x minus 2 cosine of x. If we expand out this 16x to the 4th power, we do the expansion because it's easier to see when we take a factor of 4 out and a factor of x out to leave 4x cubed at the bottom. That's negative x sine of x minus 2 cosine of x over 4x cubed. Then let's try to look at another problem, number 11. Let's look at number 11. Number 11 says a particle moves. Let's see if we can do that real quick. Okay, let's look at 14 real quick. Let's look at 14 real quick. F of x is equal to cotan of x. Find the equation of the tangent line at x equals pi over 4. Now, if the x is equal to pi over 4, the point is pi over 4, and cotan of pi over 4, which is pi over 4 and 1. The slope is the derivative of cotan, and we know the derivative of cotan is negative cosecant x squared. Squared x, I'm sorry. So that's going to be the negative cosecant of square root of pi over 4, that is negative 2. So in part and slope form, we have y minus 1 is equal to negative 2 times x minus pi over 4. And that is our point and slope form. Thank you so very much for watching, and see you next lesson. Have a great rest of your day.